Any question over any of the homework assignments? If there's no question over the homework assignments, we're going to go on and start looking at the lesson for today. Now, how we solved problems like this yesterday, these exponential equations, was we got the bases to be the same. So if we can get the bases to be the same, then the exponents are the same. So the first main question is there any way that I can rewrite 7 as 2 to a power? Because 2 squared is 2 cubed is right. So 2 cubed minus 1, but that's not going to help us too much because then we'd have two different numbers, and it doesn't work that way there. So we can't rewrite 7 as 2 to a single exponent. Now, what we can do instead is apply a logarithm to both sides. Now, we're going to apply a special logarithm, or not a special, but a certain logarithm to both sides, because we're not just going to use any logarithm. I'm going to use log base 2. And there's a reason for that, and mainly I'm using this because we only have a variable in one of the exponents, so we're going to use log base 2 and apply it to both sides. Now, part of our properties of logarithms, the power property says I can take the exponent and move it to the front, telling us that we have x times log base 2 of 2 is equal to log base 2 of 7. Now, my next question for y'all is, what is log base 2 of 2? What is log base 2 of 2? Well, we can clear all that out. And let's go math. Log base 2 of 2 is 1. Because one of the properties that we had was that log base b of b is 1. And we could show this pretty easily, because if we said x instead of 1, if we wrote this as an exponential, we would say b to the x is equal to b. Well, the only way this works is if x is 1. So whenever the base and what's inside the logarithm are the exact same, it simplifies to 1. Really telling us that we have x times 1 is equal to log base 2 of 7. Well, this is really just telling us that x is equal to log base 2 of 7. And now at this point here, we're going to approximate to the nearest third decimal place. Now there's two ways we can calculate it. One of them is in the calculator, the graphing calculator. We can go math and select log base 2 of 7 and hit enter, and we get this here, 2.807. And that'd be our answer. Now the other way we can do this is with our change of base. Now, hopefully you remember the change of base. Well, y'all watched it last Friday. We went over it last Friday. And the change of base just states that log base b of x is the same as log of x over log of b. Log base b of x is the same as log of x over log of b. Or we can say the natural log of x over the natural log of b. And in our case, it would be the same as saying log of 7 over log of 2, or the natural log of 7 over the natural log of 2. And we can use the other calculator and say log of 7 divided by log of 2 gives us the exact same number. We could also use ln, so I can say ln of 7 over ln of 2, and we get the exact same number. So if we don't have the graphing calculator at our disposal, we can use the change of base formula to calculate it as well. Questions on this here? And the biggest thing with any of these here is to get the number with the variable and the exponent by itself first. And this one here and the last one already have it by itself. Now what we need to do next is apply log to both sides. But what log would we apply? 3. Log base 3 to both sides. Because if I apply log base 3 to both sides, here the x comes out front, telling us that we have x times log base 3 of 3 is equal to log base 3 of 8. Now log base 3 of 3 will cancel, simplify to 1, telling us we have x is equal to log base 3 of 8. And we can calculate this here. Now before we calculate it, what do we think x should be close to? What integer value?
Wait, what?
What value of x do we think, or what do we think x should be close to? What whole number?
3.
Because 3 times itself, how many times? Well, once is just 3, yes? Twice is 3 squared. 3 times 3 is a little bit bigger than 6. 3 times 3?
Oh, wait, say that again.
3 times 3?
3 times 3 is
9. So 9 is bigger than 8, yes? So we should expect x's value to be smaller than 2, but not by a lot. And if we plug this in, log base 3 of 8, we can go math. Log base 3 of 8 is 8. So 1.893, yes. So again, it is a number close to 2, because 3 squared would be 9, so we get a number close to it. Now, if we wanted to, I could plug this back in, say 3 to the 1.893, and what number should we expect to get? A number close to 8. Now, we're not going to get exactly 8 because, again, log base 3 of 8 is not exactly 1.893. It is approximately 1.893. Because if we put 3 to the 1.892, which is a little bit closer, we do get a number closer to it. And if we keep 1.892,789, and it's a number, as we see here, we're getting closer and closer to 8. But because we're not putting the full decimal, we're not going to get exactly 8. And logarithms, there's no real good way to get the full number.
So this one, you plan to add the log base 3, whatever the whole number is.
So what would we do for this next one here?
Log base 7.
Yes. We can apply log base 7 to both sides. Now the 9x is going to come down according to our properties of exponents, yes? What's log base 7 of 7? Well, it's going to reduce to 1, yes? So really this one side I can just consider to be 9x is equal to log base 7 of, is x by itself? Is the log base 7 of 15 going to be a nice number? No. So instead of approximating anything at this point, we still do need to get x by itself, and we can do that by divide both sides by 9, telling us x is equal to log base 7 of 15 over 9. now we need to calculate this here. Alpha y equals enter. Math. Log base 7 of 15 all over 9. 0.155. And we get our answer. Questions on any of this here? So, what can we do first? Y log base 5 to both sides. Now we'll move the 3x plus 7 to the front. I'm going to rewrite this one out so we see it. 3x plus 7 times log base 5 of 5 is equal to log base 5 of 311. But we know this whole number is 1. Now if it hadn't been 1, we would actually need to specifically multiply by each term. We're going to do that anyways, but 3x times 1 is 7 times 1 is still 7. If we had something different, we would actually need to multiply it through and go from there. Now the other side is going to be log base 5 of 311. So we don't have x in a variable anymore, just like the previous ones. Is x by itself?
No.
So what do we need to do first?
Subtract 7.
Now we wouldn't subtract it from the 311. Right. So we can't actually subtract it from 311. So if it had just been basic log, we do need to make sure the parentheses are around it. Because without that second parentheses after the 311, the one to close it, it would subtract it from the 311 and then take the log of it, which would give us a different value. The next thing we would do is divide both sides by 3. Telling us x is equal to log base 5 of 311 minus 7 divided by 3. And at this point here, we will plug it in. Alpha y equals enter. Math. Log base 5 of 311 minus 7 all over 3 is 1.145. Any questions on any of this here? We good with this here? Well, this here is no different than what we've been doing. It's the exact same. If we feel comfortable with this one and this one, we'll move on to the next one. Now with these here, these are a little bit different, but not by a whole lot. Just like with the previous ones, we needed the number with the exponent by itself, but we actually didn't have to do anything to it because it was already by itself. Here, our number to an exponent is just e. So in these cases, we do need to get e by itself. So what's the first thing we can do? I would add 7. Now, dividing by 4 is not wrong. It is a proper step, and we could do it, but I would have to divide the 7 and 13, yeah. It would get us to the same place, but we would have to deal with some decimals before we got there. Now, we can divide by 4, telling us e to the negative 0.3x is 5. Any questions on any of this here? Now we do need to get rid of e and get the exponent out of there. Now just like with the previous ones, we can use logarithms. Now we want the base of the logarithm and our base to be the same, yes? Now e, we didn't just use any log, we actually used what? ln, because the natural log's base was understood to be e. And if we use ln, the properties of exponents still hold true. We can move the exponent to the front, moving the negative 0.3x to the front, again giving us ln of e is equal to the natural log of 5. But the natural log of e is what? 1. I think that's kind of creative. ln of e is 1. E. So it simplifies out, just leaving us with negative 0.3x is equal to the natural log of 5. Well, last but not least, we need to divide both sides by negative 0.3, telling us that x is equal to the natural log of 5 divided by negative 0.3. Now, the natural log is kind of nice. We can say the natural log of 5 divided by negative 0.3 is negative 5.365. And that's it. Questions on this here? Questions on anything we've done so far? So is this here a whole lot different than what we did on the other ones? No. You can write x equals negative 5.635. It's not going to specifically state to round to the first 3 decimal places, but it's going to want you to round to the first 3 decimal places. Go out 3 decimal places, and that's your answer. On the test, for sure, I will look at your answer rounded to 3 decimal places first, and if this is off, I will look back at this to see if you got this right. Because if you got this set up right, but then this wrong, that's just a calculation error. I'll still give you the points because you did all the steps right. It was just plugging it in that was wrong, or something was off, and it could be minor. Calculators are not nice that way. Any questions on any of this here? Do we need to see another example of one of these? We feel comfortable with these? This is the last type we're going to look at. Log base 2 of 5x minus 17 is equal to 3. Now we said earlier today that log base b of b was 1. Whenever the base and what's inside are the same, it simplifies to 1. Now we had another property, b to the log base b of x. And this worked out to be x. So if we put a logarithm base to the base, so b to the log base b of x, the b and log base b simplify out, leaving us with what's inside the parentheses. So if I was going to use that here, what can we put both sides to the base of? 2. Because this 2 to the log base 2 will cancel out, leaving us with now up to this point, whenever we did our first step, especially today, in solving, what we ended up getting was not a nice number, right? Is 2 to the third going to be a nice number?
So yeah, well,
Yeah, it'll be 8. And again, the way I phrased that was a little misleading. But this here will actually give us a nice number. And at this point here, we just need to solve.
I said it. 25, so divide that, so x equals 5.
That's it.
Okay, where's the homework book?
Do you feel comfortable with this here? We can look at one more of these here. I'll let y'all walk me through this one. So what would we do first?
So,
Put both sides of the base at 3. Equals.
that would cancel, so it'd be 10x minus 9 equals
3 to the 4th.
81, add 9.
Add 9. Yes. Divide by 10. X equals 9. And the only thing we do need to still be careful with is that what's inside the log whenever we plug the number back in, that this does not finish up as negative or 0. And it's not so much that the value of x is negative or 0, but what we finish up inside is negative or 0. It is possible for x to be negative, but if we plug it back in, it can't be negative or 0. Does that make sense? Well, that is it. Now, we can't have quadratics. There's one of them on the homework that is a quadratic. Once you get it equal to 0, just graph it, and that'll give you the answers. But that's